All right. We're back with more coding content today. Let's get cozy and let's continue the DSPy series today. All right. So I kind of, because we haven't done that in a while, and the project is getting a bit complex. So let's remember the diagram, our favorite diagram, right? Let's see, how do we move this here? Oh, is it like this? Yes. All right, so this is what we had so far. Last time I remember we worked on data, and we actually did a pretty good job because we found this lead code problem style data set. And oh yeah, we had to parse it. We had to parse the problem description to extract the input-output pairs from it. I think that was pretty successful though, from what I remember. So we'll revisit that. And I remember we ran this on another problem, and it actually worked. When I say this, I mean the whole spaghetti we have, right? Which at the center of it, we just want to solve competitive coding problems, but we want to solve them in any programming language, not necessarily in Python. And we also want to output multiple pieces of code. When we say we want to solve a problem, we want to output a solution code, but we also want to output code that profiles the solution, memory and runtime, and test code that exercises everything, including the input-output pairs and the profiling code. And we spent a lot of episodes in the previous episodes in the series figuring out that it's not that easy to do, because at the very least you need to generate instructions for the model to actually use the solution in this code. Otherwise, models may be sometimes tempted to redefine the solution in the test code, which kind of defeats the purpose. Then we also spent some time writing this project structure to file. And we also wrote, then we wanted to extend it to any programming language. This part was a bit tricky, but we did it. We wrote a project manager which sort of generates meta instructions on what kind of use statements or import statements or include statements should be used to link these files together, the files which are to be written on disk. And that kind of work, we haven't really tested that on other programming languages. I have an idea for an architecture there, because sort of we want to cache that solution. If it works once for many Python programs, we don't need to do that at runtime. We may just want to save this, the code that the project manager generates. Now we need this final piece. Maybe we'll look into this today, because so let's look at some of the code now. Let's see, what did we have here? Well, one of the most important pieces, so let's start from the main, right? So let's see, what do we have here? What branch am I on here? Main. Oh, I didn't push something, that's fine. Okay. UV sync, okay. Let's clear the cache. I think we gathered a lot of cache from our previous series. Oh yeah, UV is very cache heavy, we know this. So it's good to clean the cache every once in a while. Okay, so let's see, how does the main code look like? Well, pretty clean. We have this project structure, which is, so the goal of this main a few episodes ago was to make this completely programming language agnostic, and we were successful because the project structure just talks about files, doesn't even have extensions, and it's pretty safe to say that the file is a universal abstraction, so it's not tied to a Python file or C file or Rust file. So we're good there. Then we have our model, DSPy, pretty basic, folder structure. Oh yeah, right now we need a big for loop. We have our signature with 2 inputs, 1 fake input that informs the signature what the project structure is, and 5 outputs. We didn't really use this explanation yet. And the 4 code outputs, which will be written to 4 files informed by this project structure. And there's 1 extra file, which is the input test cases. Then let's see, for each sample, we write the test cases to file. So we extracted it. Now comes the dataset portion, right? So we load our dataset, which is this lead code dataset that we found on Hugging Face. Yeah, we expect a certain template because we had to parse that lead code template. We do some safety checks and we write the cases to file. Then we form the inputs for the model and we predict. And this is where we left off last time. Now, the language itself is a giant parameter. So actually, let's give this code a seed, I guess. So it already has a train test split, or a train validation split. Yeah, let's give our code a seed. I wonder if we should switch to Omega Conf now. Probably to Hydra and Omega Conf, right? We can crib from our project yesterday. But that's kind of boring. Let me just give this a seed argument. The reason why I give it a seed is because I want to test this right now on a few different problems, just so we remember what does it write. So type in, and usually I use the default, the current year, 2026. RNG seed. What do we want to see? Do we even have NumPy here? UV pip list. Grep. Oh, we can't. I'm not on Linux. Yeah, we do. I wonder how does Hugging. Let's use the Python random module. We don't need NumPy, right? So let me look at how to get an RNG. With a seed. Yeah, so random seed. A. Okay. So we can seed it, which we should. I guess let's do it here, right? Random seed args.seed. Okay. Well, no, we should do it in main. RNG. Get the DSPy language model. Does DSPy language models, they don't have a seed, right? No, this wouldn't make sense. Nah. Well. Oh no, because we can't control this. It's on open router. Sorry, this is not a local model. So yeah, they wouldn't have a seed. Okay, so we seeded the RNG. How do I get numbers then from it? Whoops, not this. Function for bytes, not integers. Rand range, return randomly select the element from range. Start, stop. How would I permute something? With replacement. No, we want without replacement. Oh, shuffle. Okay. Shuffle a mutable sequence, return use sample. So let's shuffle let's walk through the train samples. Length DS train. And let's just shuffle this, right? Is a range mutable? A good question. Actually, I don't know this one. Import random. Train IDX. Range 5. Random shuffle. Train IDX. Nuh-uh, it is not. What, do I have to convert it to a list? Is this gonna work? I think so. Okay. And yeah, this should work in place now, right? Train IDX, train IDX. Okay. So we shuffle the data. There we go. And then what I want to say is for... Actually, can I shuffle? Is DS train shuffleable? Ah, interesting thought. Let's try to shuffle DS train directly. So we can exit this one and we can just do UV run -m stream.main. So can I do a random? So what is type of DS train? I don't think this is, I would be surprised if this is... Nah, yeah, it doesn't support item assignment, so it doesn't have the method implemented. Okay, so we have to do it manually. Which means we're gonna have to take sample is DS train of I. And we're gonna have to do for I in train IDX. There we go. Yeah. Okay, so now this gives us some control. The other thing I wanted to do is we wanted to filter the data set, I think, just for easy problems. Let's see, what do we have? We have a sample, okay. We have a description. There we go. Given the root of binary tree, return the length of the longest, blah, 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 blah. And we have cases. Okay, now we don't know. Print sample. What keys do they have here? I forgot. Sample. Problem description is what I want. Aha. 1, 2, 3, 2, 2, 1, 3, 3, and the cases that I extract are 1, 2, 3, 2, 2, 1, 3, 3. This looks pretty good, so we're able to parse this and extract cases. Let's see if our RNG works. If I run this code again, do I get the same problem? I really should. Next, desk, next, desk. Yeah, we get the same thing. Cases. Nice. Okay, so no. So we have data that's controllably shuffled now. We run inference. And let's also save the history. Now, oh, I know what we need to do. We need to make the, yeah, so we're logging per sample. I guess we'll have to make let's make a history folder because we don't want to nuke our files, and we're gonna call this history. Well, actually, no. This should be in the output, right? Let's move this log, actually. No, that's better. Let's do it this way. Because we're gonna have to... Okay, so let's work a bit on the saving results for each sample architecture, because we would like to persistently save the solutions for each sample. Right now, everything writes to a thing called output. Here's the problem. The folder structure and the signature which inherits it arg's project name, which is output, but we're gonna have to make this dynamic per sample. So first, let's create this signature, and then for each sample, inject the language once. So I need to replace the field. So replace the project structure with a sample specific one in the signature. Okay, let me make this bigger. No, actually we can make this smaller. So what that means is I need a new signature. But we're gonna have to move the module here. So yes, because of the way we did our architecture, if I change the signature, I gotta reinstantiate the module too. It's not the best choice. But how else would we do it? So we can call this the problem-solving template or generic. We call it generic because it references a project in project name and for that language, but we want problem solving to be problem solving generic with updated fields. This is what we want, right? So name of the field to update the string. So we want to update the field project with, so we're gonna have to do a sample project. Sample project structure, which starts from our project. We should not initialize modules here anymore. Yes. Actually, do we even need this project structure then? No, we do not need this. We just depend on the args. I think we can pull this out actually now. Well, no, we can't because we depend on the args. Yeah. So what was I saying? Oh, I see. So the sample project starts from the project Oh, there is no because I removed it. Okay, so it's just get project structure, but not project name. Is this a path? It's just a string. So we're gonna pathify this slash. So it'll be output slash sample Do these problems have a title? That would be nice. Otherwise we'll have to use I here. Sample 0, 1, 2, 3, whatever. Okay, so we want to replace project. The type is still... What does this return? A project, okay. Oh, so it's still a project. And we want to replace it with the new values. So just the desk then, right? Desk equals sample project structure, okay. And we also have to feed it here to the module. And here, and here. Oh, this is a path. We want a path. So maybe we just leave it a string then. So it'll be args dot project name slash and I have to run init here. Interesting. So I'll have to override the class. And what method do I have in this project? Initialize modules, because that's the template, right? Yeah, the template for the PM always has initialize modules. Okay, so we want to call this. Okay, that's it. So now after all this thingy here, we did all this just so we can now see. Oops. So we're gonna see output, but we're gonna see output slash sample, whatever that sample number is. And I have to write the history. Yeah, I don't actually need a DSPy prediction. We have to write the history somewhere. Let's give this a name, sample directory. Okay, and we're gonna write this in sample directory slash history. At this point in time, this should exist, so it'll be, it's gonna be like a fly on the wall there, but it's fine. All right, yeah. Text files should be fine in any programming language, Python modules, whatever. Good. And then let's stop, because if we keep this running, waste our credits because it'll keep solving problems. So let's see what happens now if this works. Okay, it looks like it works. Sample 458. Okay. Writes the cases. Yep, that's what we want. First starts with the cases. Now the AI is thinking about the solution. It seems like it's done, which is pretty nice actually. Yep, sample 458. Solution, nice. Test from import cases. Measurements. Interesting, it did not reuse the well, there's a lot of problems here. Oh, I see. No, because oh, this is actually a very complicated example because I have a build tree function. Wow. Actually, I didn't even realize this. For like some competitive coding problems, the test code becomes very complex. Nice, but haha. So we need a shared test file or a utils file. Interesting. Let's go down this path. This is pretty interesting now because we're gonna have to change our project, but everything works. So let's see if it works. So if I run uv run -m, now the problem is I did not make this output. Actually, can I even do this? Sample 458 dot test. Yes, I can. Okay. So test results. What does this mean? Results. Is 1 the right answer? What are the cases? No, it's 2 and 3. Yeah, the problem is not solved correctly. That's a different problem though. Return the length of the longest consecutive path in the binary tree. So let's read, we have to read the problem because I don't know what's happening here. I don't know what, given the root of binary tree, return a consecutive path is the path where the values of the consecutive nodes differ by 1. One, two, three, four, 4, 3, 2, 1, 1, 2, 4, 3. It's not because you have a skip of 2 here. Well, this grammar is so bad here. On the other hand, the path can be in the child, parent, child order, or not necessarily be parent, child. I don't understand what this means. 1, 2, 3. Yeah, there's a path of 1, 2, 2, 1, 3. Oh, I see. So child, parent, child. So the path can go through the back. It can go up and down. Oh, I see. So it's like a inverted V type of path. Yeah, you can start from a leaf and end at another leaf somewhere. Yeah. Okay, yeah, so the answer is 3 here because you start from 2, you go up to 1. Well, no, sorry, you start from 1, you go, assuming this is root left, right. So you start from 1, go to 2, and go down back to 3 on the right side. Okay. Right, so then this problem was too complicated for AI to solve. Interesting. But our code actually works, which is pretty wild. Like, let me change the seed to get a different problem then. If I just run uv run -m, what was it, stream.main with a seed of, I don't know, 2027, I should get a different problem. And I should see output, another sample being written. Nice, sample 833 was picked this time. Okay, it has some cases, so it has 2 inputs. I'm guessing these are correct. Oh, we already have a solution. Find judge. This looks like an easy problem. Oh, no, the code didn't run. No, it did run. Oh, oh, there we go. Expected results. Okay, so now let's try to see if, so let's take a look. So from runtime, from measurements runtime, import Nah, this is a hallucination here, right? This is a hallucination because this code will not run. There is no profile function in runtime. It's directly called profile runtime. Okay, so the file structure is too brittle here then, because if I try to run this now, you run -m output sample 833.test. Yeah, can't do the import. So what? We didn't have enough iterations for the AI to figure that out. Yeah, there are some other bugs that happened. It generated some code that tries to concatenate lists or into list. Before this, it had the same issue again. So what happened after this step? Cannot import name profile. Okay, yeah. What is the test code? This is good here, but it flipped around. Okay, but anyways, this is a 30 billion model. It's a really weak one. Well, not really weak, it's a weak one. So it just didn't. Too bad it changed these. Okay, so I can fix this by hand then. If I just import these guys. No, but they're called the other way. They're called profile runtime and profile memory. Okay, now if we try to run the test code again, there we go. Oh, and it actually works, it passes. Oh, okay, so the solution is correct. Except, of course, it fiddled with the imports. So AI is not that good at obeying and generating correct Python imports. Even if you tell it... This is so weird because we tell it explicitly with the DSPy. What does the prompt look like that we build? It looks like... Where is it? Here it is. It says, when generating code for runtime, when generating code for test, use the following code to reuse other outputs. From output, import function or variable name. And it was not smart enough to... And test is the last. Is there a one-step lag here where it cribs from the previous solution? So this is the correct one. No, because these will appear in order. So by the time the AI generates this output, the previous ones are basically in context, right? So this here, it gets it right. Why does it mess it up here? Because it messes up. Oh no, here it is, response. Oh no, sorry, this is the previous history. Response, runtime. So it decides to use profile runtime, profile memory, but it changes these imports. Very close, but not quite. Is there any way we can help the AI more then? Okay, let's clean this up a bit and let's commit it. So what did we change? Oh, nice, just the main. We just need to remove this breakpoint. So now we did a nice thing because we modified all our per data point solution code storage. Okay. And I'm just pushing this at the repo where I, let's see, what is it called? Streaming? Oh no, it's not here, sorry. Yeah, so I'm just pushing this on my public Git. Okay, per data point solution, okay, good. Let me just paste this here if somebody wants to mess with it or drop a GitHub star. All right, so now how do we coerce the AI to respect the imports? Let me try another sample. So for that, we just have to give it another seed, 2028. And we also have to give it a, yeah, we should give it a break here. Otherwise, this is gonna run for many samples and we don't wanna waste credits yet. Well, I'm still... Aha. Good, I hit the corner case. Okay, good. Let's, okay, so something... So the lead code problem here, let's see. We are not able to write the cases. Interesting, so we're not able to extract the cases from this problem description in this data set that we found on Hugging Face. I wonder why. How does the raw description look like? So what case inputs do we have? Oh yeah, this is a disaster, right? Is it because it's a matrix? How does the raw problem look like? Full text. Oh yeah, it's a matrix. Yeah. So we actually extract the matrix, correct. But tabs are in. What is XA0? So this is not valid Python code when evaluated. Interesting. What is the XA0 character Windows? Non-breaking space. So yeah, we're dealing with string parsing here because the problem text has these, this is pretty relevant for matrices though. And then it has spacing. So because of this XA0, I don't understand. Why can't I evaluate this code then? So if I run AST literal eval, invalid non-printable character. Yeah, that's not valid Python code, it means, right? Or is it wait, is it? No, it ends gracefully. So it's just that I can't. It's actually something else by removing this character. Yeah. So we're just gonna have to. I'm just gonna remove this, I guess. Case inputs dot replace XA0 with nothing. Right? Okay. And then if I do AS, is this in place? No, strings are not in place in Python, right? Yeah. So I need case inputs equals case inputs. And now if I try to do, let me just do it here so we can see on the spot. And can I try this? Okay, good. Okay, so we fixed, interesting. Perfect, so we fixed one more bug, very important bug actually, because, okay, so git diff stream data set, git commit -m. We want to call this replace non-breaking, remove non-breaking spaces from cases, src stream data set. Okay, we can attempt to run our problem again now. C2028, which is sample 1284. And we are done. Okay, for entry in cases, where the heck are my measurements? Damn it. It's not. We have a meta problem now because, okay, the code is importing the solution, which is good. Also, I think this is a really easy problem, right? Let's see if it passes. UV run -m. Output sample 1284.test. Yep, it passes. Good. So the whole scheme works, except there's still a teeny tiny problem. We're not reusing these runtime. Instead, it's doing a copy exact functionality, which we don't want. So we need better instructions. There's no way to go around this without prompting. Yeah, prefill's not going to work here because we also want all of these in the same response. reuse as much code as possible. Okay, so let's do some manual prompting between different outputs instead of redefining or copying code. Functionalize the code as much as possible so it can be reused. I'm curious if I use this type of prompt, is this enough to coerce the model to actually import? Because it has instructions that tell it to import. Now we're also telling it this. You would really hope that it you would hope that it obeys, right? Let's see what's happening here. Sample 1284 again. It's taking a while. The risk with over... Okay. Well, this worked now. Nice. So if I run again... the code didn't actually work though. Oh, the solution itself is broken. There's an issue here with how we pass the cases. Oh no, not sample 883, sorry. So case 0, this is good. Well, I just gotta look at these, what's happening here. So case, then it strips another one. Is it a matrix? No, it's not. Length matrix 3, so it's a list. So this fails. Okay, so matrix is not stripped there. Right, because case 0, yeah, it's the same. So then what, this guy? Oh yeah, this is the problem. No, it's not. Because length of math is not 1. Huh? Oh, it's failing at the singleton case. I know what's happening. Yup. It's failing at the singleton case. Because it's flattening the matrix to a list or even a scalar, or it's probably flattening it to a list. Yeah, okay, I know what's happening. So, but this is good. This is what humans would do too, by the way. Like, this error is, I mean, it's a weak model, but the point stands that, so math, this is fine. Yep, this is fine. This is not fine because now so I know how to fix this because you don't need to double flatten. This is the fix. And now the test. Why? Why do I still enter with 0, 0? So this should strip. Oh no. Yeah, the code is fundamentally broken for singletons. Yeah. Actually, you need it's miss. So what is it missing? 1, 2, 3. 1, 2, 3. Yeah. So this stripping should not happen here either. Oh come on. Really? No, there's no way. Now the matrix is 5, 5, right? So what? I can't do 5, 5. This is fine. This is fine. Yeah, 5, 5. So I can do matrix 0 and 0. Okay. And this is 1. So 0, 0 and 0, 0. Zero, zero. Why doesn't this work? This is so confusing. So this should actually work, right? So I got the stripping wrong. Good, good. Matt? Okay. Oh, come on. So Matt, what is N? Oh, N is a special keyword and but in any case, what is I? Okay, next. I. Okay, so what? I can't do math 0, 0? Yes, I can. Next. Next. Okay. Oh, the runtime. Yeah, there's stripping in the runtime too. Yeah. So, okay, so no stripping. Here we go. There we go. Yep, all tests passed. 140 bytes negative somehow. Yeah, the memory is also busted because it's measuring. So these are kind of just symptoms of a weak model. We can always blast GPT-5 or something, but let's not do it for now. Okay, these are all good. What else we want to do in terms of infrastructure? So we solved the data. I guess we'll leave these tighter instructions in. Tighter modularity and reuse instructions, because we can't really do much about these. Nah, it's too complicated. If we parse the code and then we can do it. I mean, the thing we can do is we can preset these in a certain language, which implies working I think it's too tricky though, because the scheme gets too convoluted. Let me turn the language on then. So what happens? Let's debug. I know what happens. What if we say seed? Let's leave the seed and we do language Rust. What's gonna happen is, well, hang on, this is not gonna have to delete the thing here. It should call the project manager. Oh, we don't call the project manager. Okay, so this is a problem now. We need to piece everything together. Because there is no .rust file. Yeah, this is still Python. Because we're statically importing from Python. So we're gonna have to organize all these. So what does it take to actually run in another language? A lot. Where's our project manager? Here. Where does the project manager write its code? src stream completed PM. So let's run the project manager for Rust then. Which is gonna be a different beast. Stream language.pm -- language Rust. Now this still writes Python code, but it writes Python code that instruments Rust code. I mean, it's gonna be very complicated. And we'll write it in completed PM. Now, if we're happy with it, we should move it to completed rust.py, but only if we're happy with it, which is a really big... Where the heck does it write it? Oh yeah, it's RS. Here it is. Okay. So RS. What else does the PM write? That's it? What is the template for the PM? Initialize modules. It's just a touch. So it's gonna write RS, but it doesn't know how to do a crate though. So the template for the PM. It just makes the folders. It's right here. So let's try to run the tests then for the PM, which is stream.language.completed.pm. The tests run. Okay, so let's see, how does it look like? Test.rs. Inside. Why do I have two files? Oh no, this is wrong, right? I was expecting to see. Oh no, 3 Rust files, right? Test, file, and meta, which is in inside. File and meta are on inside. I'm getting these weird. I'm getting. Let me try this again. I don't like how this looks. Yeah, so okay, well this hallucinated because it's writing JSON files now. Nah, this hallucinates badly. Completed PM. I don't know why I would not do dot. I don't know why I did JSON. Again, it's writing. This starts. Oh, it it actually wrote Rust code in the Python. Yeah, so there's a bit of confusion here for sure. Because we're. Oh, what happened here? Oh, nothing. We're confusing the model. Yeah, this is too complicated for it to work in one shot, right? I think so. What happens if I ask a C? So this concept... The concept of initializing modules is too tricky to... The suffix is easy. You can always guess the suffix of a programming language, but initialize modules other than to touch a file. And what is my criteria for the PM? What is the execution feedback I have here? Oh, I checked the templating, right? Yeah. And I execute the test code too. So this code executes, but what does it write? So if I run uv run -m stream completed PM, Okay, it gives me open meta. This is what I want, sure. Now what does it decide to write on file? Oh, I see. It invents a seed magical structure called cases, right? This is correct though, because there are no... But it wasn't smart enough to... What is a template? Sorry, the template for the PM. So what you can do is you can type here. The code must be standalone, runnable, and or compilable, including any data structure definitions. Because he makes this mysterious cases. Okay, we're slowly, yeah, there's no other way to improve this than by trial and error. Right, so what we need now would be a meta executor, like, but we can't do that on Windows. It's gonna be crazy because I don't even know how to... Because then we run into a problem of how do we execute code in arbitrary languages? Well, guess what? You need AI to predict that. So we kind of spin into a circle at the end of the day, don't we? Now, of course, strong models like or Claude Code or Code GPT Codex or whatever it's called, they can probably crack this. But the idea is to help weaker models as much as possible. Aha. Okay. So there we go. We're starting to see some C code here. Oh, what did I do? Did I touch something? Yes, I did. Was this me? I think so. I dragged, pasted something. Let me just run this again. But this tiny note we left in the template seems to have worked though. This looks pretty good actually. It's actually writing C code with spaces and everything. Okay, or this. But this is not valid C code though. Do I even have GCC on Windows? I don't even know how to compile C code from the command line. There's some template shenanigans happening. I know what's happening here. I'm not supposed to leave notes here. I think I need only to do. Okay, there's a mistake here because here we go. Allowed changes to do. So what, am I invalidly, I think I'm invalidly messing with it. No, because write jagged array to file. What do I do with this valid pi? Oh, I know what's happening. So code equals stuff. Does my PyTest pass? It still passes. So it's not like I'm punishing the model for removing the note. Let me try again. Something weird is happening here. Okay, here the model messed up because it touched the template on the outside. This is fine. We reset. Okay. I guess it's deciding to leave the notes in, which is fine. Yeah, this is okay, but not really, right? Because if I run, what was the command again? This one. If I run the... Yeah. The other thing is, am I running out of credits? No, it's actually trying 5 times. Yeah, this is hard to crack. And I think if we throw more feedback at it, this is not gonna work. Let me give it another try just for fun. Oh no, sorry. So we may have to go back to the drawing board and rethink all of this. It's trying some things here, cases again, but this, what is this cases though? Because it's not valid C code, right? Yeah, there's no data structure. Okay, I got the JSON thing response, so this is also wrong. There's a bunch of stuff here, yeah. So yeah, we're stressed. Yeah. What happened here? Yeah, we degenerated badly now. So we can add this. Better, more precise, but it's not good enough for small models. Let's go back to the drawing board a bit then. Let's not lose our cool here. So let us draw again. Okay, So. Nice and easy. So. I know I want... So I'm gonna have, let's see, let's call them, oops. So I'm gonna have output code files. Okay. No, so I have output code fields, which is DSPy output field. I know I have a project structure. So I have a file. And I want to write this to a file. With extension. So then I can infer the extension with AI. Okay? So then I can have a micro module. So let's do the brainy thing then. Where are we here? Okay. Let's micromanage the AI, right? So extension predictor. Aha, so this one, why doesn't it see the code then? Let's do this differently. Let's entangle the modules instead of thinking in terms of meta modules. Okay, I think we're gonna do it this way. It's gonna change the architecture drastically, but it may just be worth it, right? So, and this here is a static write. And this guy predicts the extension. Okay. And it sees the code. And it sees the mysterious thing also called programming language. So now we can take each of our output fields right, so this will be file system info. Oh no. There we go. So this will be file on disk. Sorry. Okay. And then the programming language also informs this guy. Okay. So now we have a micro thing, right? And we have DSPy code, right? So let's DSPy code. Okay. Equals DSPy output field. Well, DSPy code and DSPy output field, all right? Or an output field which is a code, which is code. Okay, so now we will be able to write these. Ah, but no, wait, there is more. What else goes in here? Project structure. We need this too, defined ahead of time. The code doesn't interact with it, so all these three things combined, yes, these are the contents of the file, this is the location of the file, and this is the extension of the file. And this is a static right op here. Static means non-AI, right? Like we're just gonna use any type of programming language or scripting or whatever. So now we have our fields organized in files. Do I need anything else then? Because this has the paths. Right? So all these things combined, they give me my file on disk. Do I even need a link like this? I don't think so. Like, does my programming language need to inform my project structure? This is a good question. It definitely informs my code. So this is predicted by our problem solver. Okay, so yeah, this guy's responsible for producing the fields, which are code. Of course, it's aware of the programming language because it must be requested to produce code in a solution in a language. Is it informed by the project structure? Yes. Through the adapter we wrote. Trying to see if there's any logical loops here or not. Okay. And this generates prompts for the competitive coding problem solver that tells it how the outputs interact with each other. I think this I'm gonna cut, all right? I don't see it yet. But the file adapter is also language dependent. Okay, so here's the part we're missing today. Okay, so this part depends on the language, and it generates an adapter, and on the project structure. And generates an adapter. We're missing all this today, but this is kind of what we want it to be. And does the language inform the project? I think this is the... So we can write all these. Yeah, so then the adapter generator is the starting point. Then competitive coding problem solver. We're gonna have to do this, but for now it's fine. It's missing. So where am I entangled today? We just redrew the same thing. So what do we have today in the template for this so-called project manager? We have a suffix. I think we're gonna have to ditch the initialize. We had trouble with the right. Okay, we have to draw the data in too. I know what's missing now. So, So this one can become, let's say, sort of a, dashed line, which is okay. Now, what goes in a competitive coding problem solver? Two things, one of which is not important. The most important thing is there's some input-output pairs. They go in text form here, but that's not what we want. We want them here. So how do these become file on disk? This is the missing link. Because this is not easy. This is what we're dealing with right now. Simple, with a specialized AI module. Okay, this is the problem. We need this guy to be super specialized. So this will be an array writer. Okay, I know. Yes, this is it. So we need a new DSPy module called an array writer, which honestly doesn't even need to be aware of this structure. That part we can handle statically. The biggest problem by far is that this is hard to do in the generic programming language. So then we need this guy. This is gonna be natural language. So this is like this. Yeah. So we need an array writer, which takes as input some input-output pairs and generates a completely standalone file. It must be standalone in whatever programming language we choose. This file cannot import anything. I think we need a judge then. So let's say this guy, oh man, we're running out of space here. It's fine. So again, we need an array writer, which produces input-output pairs, but in the green version, which is now code. Here it is. Yes. And oh no. And we also need this is fine, but we're gonna need either execution or a judge here. The project structure is easy. The problem is not writing this to a file, because we're gonna have the extension predictor, which contributes to writing the file on disk. The problem is yeah, we're gonna need a array judge. The problem is I want to say static execution, but I don't know how to execute code in an arbitrary language, so forget about it. That's it. We don't know. We have to use AI. That's kind of the whole point, right? Yeah, so this will have to be a closed loop. And this is the array file, standalone and valid. This is what this judge needs to predict. And that's it. I don't think we can have test code here. Let's make it even more complicated then. Execution judge. Code judge. Let's call this test generator. So it takes this. Now, of course, I forgot to draw here, but the code judge is also... actually, let's do it this way. Let's duplicate the programming language here because it's the same, right? Because then we can do some trickery like this. And also we can do this. Nah, this test generator is gonna be impossible because I still need the software installed and I don't know. Nope, this is too complicated. I don't know how to do that. This seems manageable. So we're kind of almost there. We just need to split the current templating into two. We have the solver, we don't have the adapter generator. We'll have to do this too. But the goal of the adapter is to import use statement instructions. So this can be natural language. This is not that strict. There's no code to execute here, actually. I think this is gonna be one of the easier ones. It's not as scary as it sounds, because this guy will see into the project structure and I'll just have to make some small statements up. Okay, so yeah, we stress tested it today and it did not work for C, mostly because this array, it is not that easy to generate a self-contained array to disk in an arbitrary language, we learned. Doesn't even work with C because it hallucinates. Let's see, what do we have here? Well, let's try again with C just to see the problem, right? So today we also try to run the PM for other languages, which becomes very hard because we lose the execution capability. Even if we had another AI that would generate execution code, it then becomes a toolchain installation problem code. which I don't want to deal with because I don't want to install. I don't even know how to run. Oh, here we go. So, okay, so first it violated the... Oh, here's a... there is an attempt here. This is kind of what should... Okay. There. Okay, so something like this. This is one of the more successful attempts, actually, because this is a standalone contained C array. Oh... But it's very complicated. It's actually a struct with a type and the union between... Oh, I see. It's... Yeah, it's a recursive structure. Wow. I think this is actually how you do it in C, because the arrays we have are very complicated. The hint is here, right? Because... so it's picking up type hints. Right, so the cases is a list. Yeah, but this is what we want though. This is exactly the AI's job, the array writer's job. So let's see what happened here. Yeah, so we have a bunch of code, but of course it's not valid Python code, unfortunately, because of this, which we can fix by hand. Let's assume that was fixed. I'm just curious, if I run now, uv run-m stream language completed PM. There's still issues with the file. What is happening here? Why can't I right case test array to file? Test array. Hey, thanks for stopping by, first time chatter. Kind of struggling here with debugging. I cannot help you with your derivative. So what was I saying here? So we're struggling with the C. It's trying to do so. Why am I getting this error though? What's happening here? Completed PM 101. Okay, I have to debug this then. File dot path with suffix. So what am I trying to write here? Test array to this file. And somebody forgot to write make dears. Yeah. This is my mistake here because this should be static. Yeah, I think initialize modules is a static method, right? Because I already give it the folders in the project. Why would I leave the... Okay, there is a simplification here. Okay, then this is easy. Trivial, because of our template, we can just delete the to-do. Okay, good. Actually, this is good. So we look in the completed Python. There we go. So for file and cell files, make the parent. And that's it. By deleting the to-do here, we... Whoops. So we have import OS. So we actually degrade the AI from some responsibility. Let's try again the... Actually, we can try the completed PM now. Where is the break? Oh, I have to change... Okay, so let's pretend the AI obeyed us here. Okay, I think this is good actually. We cut 1/3 of the complexity down because now the AI doesn't have to worry about writing, which I don't know why we did this in the first place. This should be always like this, right? Okay, so now let's try running the completed PM. Aha, good, it works. Now I'm curious to see what it wrote here. Oh, this is, wow. Almost. Why are there nulls though? This is almost there though. There's a nested struct. No, there's an array of cases. Why did it not write my value? What is that null thing? Oh, okay, it just writes null. It was not smart enough to actually write the values here. Well, because these need even more unpacking. It's closer. Let's try it again one last time. It's definitely... Let's try it again after we remove the... Because we don't need the AI to create to write code that creates folders for us. And I can delete this output meta. Oh, again, we have DSPy issues with the template, with the response extraction, it seems. This looks like Python scale to C string literal and length. Nah, DSPy. I'll try one last time. Yeah, this code is too complex for for the weak model. So we just need to break it into pieces. I think that's the better choice for weaker models because you want these guys to be specialized. Honestly, the extension predictor is going to be trivial. It'll be like one-liner. Maybe there's a difference though in C because you have H files, like header files or C files. But it doesn't really matter. The array writer, we'll just focus on the array writer next time. I think this is a good plan because it's really a tough one. And I still don't know how to test it though. Doesn't seem like there's a generic way. So we're gonna have to do it the judge way. Okay, what did it try again? Some things. Okay, this looks... Yeah, this looks... Okay, it actually almost... Okay, it's nested, it's doing bracket, C repper. This may be way closer. Let's try to run this PM. Okay, it wrote to file. Is it a good... Okay. I have no idea if this is valid. So let's emulate the judge then, because I go to Gemini. Except one problem, the judge is also gonna be weak. Is this valid C code? Suggest syntactical fixes if not. This will be our judge, but we'll systematically route it with DSPy. I don't even... Structure is valid. You can use square brackets. Yeah, this is not that easy, right? Wow. Yes, this is what yes. Show me a construct. I mean, this is what we want. I'm basically asking for an array writer now. Factory style approach. Create nested array. Well, this doesn't look that easy. But Gemini is also a smart model. So we know we're kind of on the right path, except we're using a weak model. So next time we'll figure out what we can do. Yeah, okay, so this is a good plan. We'll focus very... Okay, so let me upload the template though, because we did do a very important fix. We changed the template a bit. Yeah, because we're degrading. Actually, we don't want the AI to do that. So don't have AI initialize modules. Let me also add this test here. Stronger test. Okay, so next time we'll figure out what to do with the this type of array writer and judge. Okay, it's gonna be pretty interesting. It'll be difficult with a weak model, but it should be pretty interesting. So I'll see you next time. Thanks for stopping by or tuning in.